Okay, so for video homework week 4, the problem is a hollow sphere located at the origin with a radius of 10 centimeters has a charge of 30 around its surface. An electron is placed 10 centimeters away from the sphere to the right. The objective of this problem is to find the electric field due to the sphere and use this to estimate the new position of the electron 0.1 seconds later, assuming that the electron starts at rest. Here's a diagram that I've drawn to illustrate the situation, and as you can see, there's a charge of negative 30 on the surface of the sphere, and the electron is placed 10 centimeters away from the sphere with an initial velocity of 0. And it's important to note that the electron is directly to the right of the sphere, so it only has a position in the x coordinate, so there's no y or z coordinate at the moment. So the first thing that we're going to have to do for this problem is solve for the electric field due to the sphere. And to do this, we're going to use the electric field equation for a hollow sphere, which is 1 over 4 pi epsilon naught times the charge over the distance squared. So once we plug in our numbers, we get 99, which is 1 over 4 pi epsilon naught times negative 30 e to the negative 6, since we're changing to coulombs there, divided by the distance away that the electron is, which is 0.1, and that squared times r hat. And when we do this, we get that the electric field due to the sphere at the observation location of the electron is going to be negative 2.7 e to the 700 newtons per coulomb. So once we have this electric field, for it to be useful to us in this sense, we're going to have to turn it into a force. And to do this, we have the equation that the force equals the electric field times the charge. Plugging in our numbers using the electric field we just found, multiplying it by the charge of the electron, we get that the force is equal to 4.33 e to the negative 1200 newtons. And so before we move on to predicting the new position of the electron, I just want to point out that since we know that it's a negative charge on the surface of the sphere and an electron has a negative charge, the electron should be moving away from the hollow sphere, and so that's just a good thing to keep in mind when moving forward, because if we get anything different, then we might need to go back and double check our calculations. So moving on, the first thing that we're going to do now that we have our force is use the momentum principle to find the new momentum of the electron 0.1 seconds later. And so how we do this is we're going to take the initial momentum, which is 0, and add it to the f that we just found, multiply it by the delta t, which is 0.1, and that gets us 4.33 e to the negative 1300 kilograms per times meters per second. And so then using that new momentum that we just found, we're going to go to the position update equation, which is r final is equal to the original position of the electron, which is 0.100, and then added to that new momentum that we just found divided by the mass of the electron times our delta t. And crunching the numbers, we get that the final position of the electron is 4.76 e to the 1600. So just that small charge on the surface of the sphere caused that one electron to shoot a very far distance away from the hollow sphere. And since it went away, we can assume that our calculations are fairly accurate. Thank you.